What if everything around you, your thoughts, your memories, your senses, is not what it seems? What if the world you know, the people you love, the goals you chase, are nothing more than data? This isn't just the plot of a sci-fi movie. It's a serious question that's gained traction in philosophy, physics, and computer science. So today, we're diving headfirst into one of the most mind-bending ideas of modern thought: the simulation hypothesis. The notion that reality might not be real isn't new. In ancient Greece, Plato described a group of people chained in a cave, mistaking shadows on the wall for reality, only to discover that there's a whole world outside the cave they've never seen. Centuries later, René Descartes questioned the trustworthiness of our senses. For all we know, he argued, an evil demon could be deceiving us into believing in a false world. These weren't just mental exercises. They reflected a deep human suspicion that what we see might not be all there is. Fast forward to 2003, when philosopher Nick Bostrom at Oxford University introduced what's now famously known as the simulation argument. He proposed a trilemma. One of three things must be true. Either 1. Civilizations like ours go extinct before developing the capability to run large-scale ancestor simulations. 2. Civilizations that do reach that point have no interest in running such simulations. Or 3. We are almost certainly living in a simulation. Bostrom's logic was simple. If any advanced civilization runs even one ancestor simulation, and each simulation contains simulated beings that themselves create simulations, then the number of simulated minds could vastly outnumber biological ones. In that case, what are the odds we're among the few originals? But here's the twist. This isn't just philosophy anymore. Rapid advances in computing power and artificial intelligence are beginning to blur the line between simulation and reality. In recent years, researchers have used supercomputers to model everything from weather patterns to galaxy formation. The Illustris and Eagle simulations, for instance, create virtual universes so detailed that they can mimic the evolution of real galaxies. These aren't just pretty animations, they follow physical laws with mathematical precision. If we can do this with just a few decades of computing, what might a civilization millions of years ahead be capable of? Now consider this. Your brain is essentially an electrochemical machine interpreting input data. If that data were simulated with enough resolution and consistency, would your consciousness know the difference? Could a digital mind be as real, as self-aware as you are right now? Some computer scientists argue that consciousness could emerge from sufficiently complex information processing. If true, then simulated beings could be conscious, just like us. Of course, all this rests on the assumption that simulation is possible. But would it even be computationally feasible to simulate an entire universe? That depends. Some theorists argue you wouldn't need to simulate everything at once. Like a video game that only renders what's on screen, a universe simulator might only calculate what each observer experiences, moment to moment. This localized rendering would drastically reduce the processing power required. Add in the weird rules of quantum mechanics, where reality seems to collapse into definite outcomes only when observed, and the idea starts to feel eerily compatible with a simulation model. In fact, quantum mechanics is one of the areas simulation theorists love to point to. Take the famous double-slit experiment. When particles like electrons are fired at a barrier with two slits, they create an interference pattern, suggesting they behave like waves. But introduce an observer, say a measurement device, and the pattern disappears. The particles decide to act like particles instead. Why would reality behave differently when observed? Is it truly a quirk of nature, or is it a system optimizing resources, only finalizing outcomes when someone's watching? Even more puzzling is the Planck length, the smallest possible unit of space. Below this scale, space-time loses meaning. It's as if reality has a built-in resolution limit, like pixels on a screen. Could this be a clue? Some physicists, like Dr. Silas Bean, have have proposed that we might be able to detect the grain of the universe by looking for specific patterns in cosmic rays, just like the aliasing effects in digital images. Another curious clue lies in mathematics itself. The universe, at every scale, appears to be underpinned by mathematical structures: fractals, symmetry, number theory. As Nobel Prize-winning physicist Eugene Wigner once asked, "Why is mathematics so unreasonably effective in describing the physical world? Is it because the universe is written in code?" But let's be clear, there's no empirical proof that we live in a simulation. Most scientists remain skeptical. Critics argue that simulation theory is unfalsifiable. It can't be tested or disproven, which puts it outside the realm of science. Others say it violates Occam's razor, introducing unnecessary complexity to explain a universe that already functions according to known laws. Still, others point out that creating a perfect simulation of a mind, including all its sensory input, emotions, and consciousness, might be fundamentally impossible. And yet, even among skeptics, there's a sense that the question itself has value. For one, it forces us to re-examine our assumptions about consciousness, identity, and reality. If we are simulated, who or what created us and why? Are we part of a scientific study, a historical archive, an entertainment system? Or are we more like NPCs, non-player characters, wandering aimlessly through a cosmic sandbox? More importantly, if we are simulated, does that diminish our experiences? Some say yes, that our joys, pains, and achievements would be meaningless if they're not real. But others argue the opposite. Meaning doesn't come from metaphysical status. It comes from the internal richness of the experience. Whether simulated or not, love feels like love. Pain feels like pain. Our lives have meaning because we give them meaning. Interestingly, a few researchers are even trying to test the simulation hypothesis. Physicist Melvin Vopson has suggested that information itself might be a fundamental building block of the universe, akin to mass or energy. His mass-energy information equivalence principle proposes that physical systems store information and that deleting that information could produce measurable effects, potentially offering experimental clues about the universe's digital underpinnings. Others have proposed more abstract approaches. Perhaps by analyzing the cosmic background radiation or the distribution of subatomic particles, we could find evidence of an artificial grid, like digital scaffolding, beneath space-time. So far, nothing conclusive has been found, but the mere act of looking suggests that the idea is being taken more seriously. There are also ethical implications. If advanced civilizations do create simulations, and if those simulations contain conscious beings, then they have moral responsibilities toward them. Are we those conscious beings? If so, what kind of ethics apply to our creators? Should simulations have rights? If our lives are running on someone else's hardware, are we entitled to demand better graphics? Or more importantly, justice? And what happens if we discover the simulation is real? Could we wake up? Could we break out? Some have imagined that enlightenment might literally mean realizing you're in a simulation and transcending it. Others worry that discovering the truth could lead our simulators to hit the off switch. This line of thinking can veer into paranoia, but it reflects a deeper anxiety, that we might be powerless in a system we don't understand. Then again, even if we could never prove we're in a simulation, does it matter? Should we live our lives differently based on this possibility? For most of us, probably not. But simulation theory reminds us that what we call reality might not be the absolute, concrete thing we think it is. It invites us to stay humble, to keep questioning, and to explore the nature of consciousness with open minds. In the end, simulation theory may be less about whether we're living in a cosmic video game and more about how we perceive existence. It pushes us to ask big questions. What does it mean to be real? What is consciousness? And why does any of this matter? Whether we're made of carbon atoms or lines of code, these questions remain as profound and as urgent as ever. So, are we living in a simulation? No one knows for sure. But the mere fact that we can ask, ponder, and argue about it, that we can question our own reality, might be the most human thing of all.